HVAC 360 is brought to you today by Big John's Portable Executive Restrooms. Tired of those stinky construction site bathrooms? Are your sensibilities offended by the politically incorrect graffiti? Introducing the Big John's Portable Executive Restroom. We'll guarantee that you'll leave lighter and refreshed each time you drop the kids off of the pool or recycle your morning coffee. Our antimicrobial commodes and fresh pine scent will make you feel like you're the chairman of the board. Methane-powered fans and heated seats are just some of the luxuries you'll experience and grow to depend on. Get your Big John's Portable Executive Restroom on your job site today. Hey, what's up? Welcome back. This is episode number 96. Matt Nelson here, your host for HVAC 360, helping you go further and faster in the field of HVAC. This is a place where I share stories, have interviews with some industry experts, and generally help you sharpen your tools in your HVAC toolbox. For those of you who are new here, definitely go and join my growing mailing list at HVAC360.com. I generate a newsletter weekly with some games and some other tidbits, information, also some continuing education opportunities, other things that I find around the internet. But in general, it's just short. So go ahead and sign up at HVAC360.com today. All right, so what's up for this week? This week I wanted to share a little bit more about ductwork layout and some of the tips I have. This is not a exclusive list or a definitive list, but it's just kind of just more information for you to kind of digest when laying out ductwork. And this is part 2, and I will get to all those tips right after a brief word from our sponsor. All right, so right now we have gone through in part 1, that was episode number 93, we went through the ceiling sandwich that kind of described a lot of the things and the steps that I go when I first approach a ductwork layout. So if you haven't listened to that first, go back and review it right now. If not, some of these things you don't really have to. But we're going to go over kind of six different topics of what I do and some of the things that I have to think about when laying out ductwork. And this is one of the things that, it needs to be elegant. Your solution should be elegant when you're laying out ductwork. This is kind of the art of the whole ductwork layout kind of production. So you just don't hammer it, just put it down there, start drawing, fast and furiously. You want to be able to plan out your ductwork layout first. And there are some points, when you get into some of these topics here, that you want to have some back and forth with architects or structural engineers. So that's why you want to kind of think it out a little bit ahead of time. All right, so group number 1, we're talking with vertical circulation elements. That goes with stairways, that goes with elevator shafts, any other thing that's architectural that's going to go multiple stories. Why are those locations important? Well, they're important for you because architects in general like to group the ductwork shafts or any sort of, multi-level penetrations in the core of a building. So you want to get them away from the outside. They want to put them in the core of the building, and they want to kind of group them together. So they're already going to have these elements in your building. So they're going to want to put those right next, or the ductwork shaft right next to those elements. So a couple of things that you want to make sure that you're thinking about when you do this. There are going to be, because they like to group everything around this central, core location, what they, might refer to as like a utility core. They'll also put electrical rooms there. They'll also put IT rooms there. And there's a few of those rooms that you don't want, if you absolutely can avoid it, don't run large ductwork through these rooms. Sometimes it's code that you absolutely don't, put, ductwork through these different rooms. But in general, it's good practice not to, to avoid them if you can do that at all. So sometimes it's not possible, and you have to make other kind of some wonky solutions to this. But in general, if you can catch it early enough and kind of have that negotiation ahead of time, sometimes with the electrical, sometimes with the IT guys and the architects, you can come out with some sort of agreement on how to lay these areas out. Generally speaking, because if you remember back to the ceiling sandwich, you're going to have a sort of minimum depth that you want your ductwork, and typically they're coming out of a shaft. It's going to be wide, and it's going to be you're going to have an aspect ratio of maybe a 3-to-1 aspect ratio, where it's going to be maybe like a 36 by 12, or it's going to be a 48 by 12. Something in that neighborhood. Sometimes it's going to be a lot deeper. Maybe it's going to go as much as 18 inches deep. But they're going to tend to be very wide. So depending on your shaft size and location, you might have to go out, different adjacent walls. They might not necessarily be able to go out the same wall because it's not that wide. And typically, you're looking for your supply and your return, and that's kind of generally what I'm talking about here. Sometimes you're going to have to deal with the exhaust ductwork. That's going to be another thing that's going to play into it, but generally speaking, you're going to have your supply and return, and they're going to be about the return is going to be slightly larger typically than your supply is. So you're going to have two places, two wall spaces where you can get out of. That's kind of what you want to do. You're going to come out of the shaft, and you're going to have to negotiate the dampers and things like that, and the access to those dampers. You're also going to take a look at, do you need to do any crossing of ductwork? Again, that elegant solution or that pre-planning is going to help you a lot in crossing large ducts. And how you actually go about doing that. Also, another thing to remember is your duct shaft typically goes, if it's a multi-story building, say you have 4 floors, you're going to have the shaft is going to exist on the 4th floor, the 3rd floor, the 2nd floor, but not the 1st floor. It is going to be, because your ductwork is going to go through that 2nd floor, and it's going to spread out in the 1st floor ceiling space, so you won't need to occupy any of that space. So the shaft is technically going to end at that floor level of the 2nd floor. So you're going to have dampers in kind of horizontal positions and things like that. So that's something that you need to think about when laying out ductwork around shafts. Also, you're going to have to deal with deeper beams. Sometimes you're going to have closer beam spacing. Sometimes the beams are going to get a lot deeper. Again, that's something that you're going to have to coordinate with your structural engineering buddies when you're laying out the ductwork. So if you're not working with shafts, if you have a building that's a single-story building, or maybe it's a 2-story building, and you might deal with roof penetrations. Obviously, the one critical thing from my experience is you want to make sure that you locate the units in a place where it's not necessarily sound sensitive right below it. Typically, you're going to have a lot of penetrations just going through the roof curb directly below the unit, and wherever that ends up, you're going to have a couple hard turns, and that's going to develop a lot of noise. There might be a lot of noise also with the type of unit, rooftop unit that you're using as well. So all that noise kind of comes through that roof penetration and radiates into the space below. So if you're above a bathroom or restroom, anything of that, not a big deal. If you're above a office space, they're really going to hate you. I've had scenarios where you have compressors in the rooftop units because it's going to be a DX unit, and they're unitized. These compressors were banging on and off, and it's not even a annoying loud sound. It's a loud sound that comes and goes, which is, for anybody who knows anything about noise, that's worse than a constant noise that you're trying to filter out. So watch where your penetrations are going through the roof. Again, you're going to have to coordinate with your structural engineers. This also applies to the duct shafts, but when you're on the roof, you're going to have a idea of how big your rooftop unit is going to be. You're going to have an idea of where your weight is distributed in that. You might have a condensing section in a rooftop unit that's much much heavier than just the coil and fan section. So you're going to have to know, and a lot of the manufacturers are going to have that data, but that's something that data is something that you're going to want to copy, and you're going to want to have give to the structural engineers so they can account for it in their structural calculations as well. They'll also they'll need to put steel around any roof openings to reinforce that. So that's kind of where you need to know how big a roof opening needs to be and where it needs to be. And that's something that you need to coordinate with the structural engineer and, again, the architect. Obviously, a roof isn't the only place that you can put a unit. Sometimes you're going to have it in the basement, and in that case, you might have a shaft that does exist on the first floor that's going up. So that could happen. Also, these going back to number one, these duct shafts, they'll also have other things in them. It might be your piping, your hydronic piping, and you're going to have to rack that in a certain way that it can also get out of this ductwork shaft, and you're going to have the same problems with those specialty rooms that are adjacent to duct shafts. So a lot of things to think about when you're laying out your system. The roof curb at the unit, you're going to have to figure this out. A lot of times you're going to want access to those rooftop units, but you're going to want them up off the roof. And typically you're going to have, and this is one of the things that it varies from company to company, but there's usually going to be a company standard about what's the minimum depth of a roof curb. How high a roof curb do you want? Because you have a couple factors playing there. If you get say an 8-inch roof curb, but you have tapered insulation on that roof, it could very well come up to that top of the roof curb. And the roof curb goes directly on the deck, whereas that's the same thing as this tapered insulation for the roof. So that doesn't work too well. So you might have a company standard saying, you know what, we're going to have at least 12 inches to account for this tapering, but maybe it's 18 inches. I've seen that before too, 18 inches above the roof deck. Once you get it too high, you have to also account for the fact that you got to get in these places. You got to be able to maintain them. If you're going to have a unit, and I think I've mentioned this a long time ago, if you're a long-time listener, but if you have an energy recovery unit that's actually, has two passes, so you have like an upper deck and a lower deck, you can reach the lower deck, but the upper deck, you have to get a ladder to access any sort of filter changes. And that can be problematic, especially if you're dealing with a wintertime condition. So a lot of things that go on with planning on a roof. Let's see. As far as the damper locations, you got to know where they are. It's easy. A lot of times it's easy to just put a damper on a drawing because it's represented by a diamond shape or a circle. That is just a symbol that doesn't necessarily represent the true difficulty that you're going to have. Again, all these things factor into beam allowances and where you're coming through the shaft openings. You might have a damper that's in the airstream or out of the airstream. What do those differences look like? One might have a actuator on the side of it if you have a smoke damper situation, where it might have an actuator to actuate damper blades. Some are going to be longer than you would anticipate. And do you have enough length before you start turning your ductwork? Because you're not going to be able to put dampers in elbows and things like that. You're going to have it in a straight piece of duct going through the duct shaft. So understand what your dampers physically look at. If you've never done that before, whoever your manufacturer of choice is, talk to that manufacturer's rep. Go through the different dampers. If you don't know, Ruskin comes up to the top of my head. I think I've referred to their couple of their continuing education classes that they put on. But Ruskin is a good damper manufacturer to take a look at what the different types of dampers are. And you need to be able to physically fit these dampers in those locations. Also, number 4, we're talking about general routing. Some general routing of ductwork. And you're going to be able to, you want to make sure that, a couple of things that you want to focus on. You want to make sure that you obviously keep it as straight as possible. You want to make sure that larger ductwork, you put it in the corridors, but realize that, the width plays a factor. You can't, I've seen ductwork that is almost as big, almost as wide as the corridor is, and actually fitting that into place and getting that secure and getting all the way around that is very, very difficult. If you can't get up to see the top of the duct and there is a joint that splits, you're not going to be able to get to that piece of ductwork and repair that location. So you might have a leak there, a substantial leak for a long time, if it's not easily accessible. So give a little space on either side of your ductwork so you can not hug them up as close to the deck as possible, even though that's generally speaking, that's where they're going to go. Since they're usually first in with a lot of these installations. A lot of things too is you want to know you don't want to run over walls. You can run through walls, and that's a choice that you're going to have to make. Obviously, depending on the routing, you might have to run through multiple walls, but you don't want to run over walls. And what I mean by that is you don't want the wall to be parallel with the duct, because being able to construct a wall. You need to be able to go up to the deck, and you need to be able to secure that all the way up there. You don't want to have to go around a duct or kind of, finagle a structural way to secure that wall. So you want to hit a wall perpendicular. Don't run over walls. Also, you want to make sure that you want to keep the number of fire dampers, smoke dampers. You want to keep that down to a minimum. If you at all can avoid areas like that, specialized areas, and again, check with your architect, make sure that you know where they're at. And, if it's something like, oh, we don't have any because we're at this sort of, classification for our construction type, make sure that if you can get it in writing, or if you can understand, okay, maybe they haven't done it yet. Maybe they haven't gone through and said, okay, this is a 2-hour rated wall. This is a smoke rated wall. This is a 3-hour rated wall. Maybe they haven't done that yet, and understand exactly where in the process they're going to start to identify what's what. So you can go back and plop down, different fire dampers, smoke dampers, things like that in your design at that time. So just don't forget about them. There's a lot of times, especially when you're dealing with a shaft, that you have to have, every time you come out of that shaft, whether it's a supply or return, you're going to have some sort of damper on that to protect the floors above and below. If you get into a certain situations where you have a smoke control sequence, that might be even more complicated, and you need to go into that a little bit further. And obviously, if it's something that you haven't done before, look to an older engineer in your company to be able to help you out in how to control units and have like a smoke control sequence for those units. Because in healthcare situations, you might end up with a situation where you have to pressurize floors above and below a fire floor just to keep the smoke contained within that floor. So there's a lot of different things that you have to account for in different situations. Not always, and obviously the simpler the easier as far as the building types go. But if you get into the really complicated building types, there are going to be additional things that you need to account for. And if you don't have that experience, team up and ask the questions, even if there is something more complicated that you need to design into the system. And hopefully you're going to have somebody that's partnered up with you and buddied up with you to make sure that you are not just left out for the wolves in those complicated building structures. You know, when you're talking about laboratories, when you're talking about hospitals, things like that have very specific things that you need to work into the ductwork system to be able to have a code compliant and a code compliant layout for your ductwork. One thing that I just ran into the other day, you know, because you always want to be thinking about when you place equipment in your ductwork, you want to be able to make sure that it's maintainable. A lot of times too, and this goes for, you know, roof penetrations. If you have roof penetrations and you have a damper at the roof, or there's some control valve that's right by the roof, that might be like 14 feet in the air. That might not be that accessible. You might want to, you know, move certain control devices either down lower or put them up on the roof in a what I refer to as a piping doghouse. If you have those valves and you can move them up there. But I mean, as far as like dampers go, make sure that they are accessible for you if you need to be able to maintain them or to test them or inspect them. Also, the equipment, like I was saying, even when you have a standard layout, I was inspecting VAV boxes, single-story building, inspecting VAV boxes. Access looked good beginning of construction. The one thing I didn't count for is they built in these soffits. They built in a display cabinet that took about a foot away from the wall. So all of a sudden, a box that looked very accessible, all of a sudden you could barely get your hand up there to, but there was no way to get your head up to look inside the control cabinet to be able to look and maintain that. So all of a sudden, boom, no access. A lot of surprises come like that when you're talking about building layout. Sometimes it's going to be, they have what is that? The wire raceway for the IT. They're going to have those cable trays put in at the last minute. And all of a sudden, it's like something that was very accessible isn't. Or you could be dealing with also the fire sprinkler system. All of a sudden, a head goes into a tile that you were hoping to remove, a ceiling tile that you were hoping to remove, and all of a sudden you can't use that as an access point to your equipment anymore. So a lot of things can go wrong. So the more planning you do ahead of time, the better. Also, number 5, I want to get into, make sure your sizes match up. And what I mean by that is that if you're tapping rounds off, and obviously if the round ductwork is the best type of ductwork to run if you're going to, as far as airflow and the characteristics there, but most of the time you're going to run rectangular. So you want to make sure that anytime you split off of that main trunk, that if you're using a round, if you're mating a round to a square piece of ductwork, that your round isn't bigger than your square is deep. I've seen that a couple of times when you have say a 10-inch deep duct in a room and you have a 10-inch round that mates up to it. There's not a fitting that accounts for that. It's a lot of times you see a lot of hammering and a lot of caulking involved in making sure that's airtight. So you don't want to get into that situation. Make sure you have, if it's a 10-inch round maximum or a 10-inch deep square duct, you're going to take a maximum of 8-inch rounds off of that. So if you have 10-inch rounds, make sure your duct is 12 inches deep. So things you can account for down towards after the terminal unit. And finally, I think the one thing is the return air paths. Obviously, we've talked about a lot here about supply. Well, what about return? A lot of times you're going to either have a ducted return or a non-ducted return, but you focus so much on getting the supply out to the space, and you get those CFMs and that cooling and heating out to the space where you need it. You don't worry about getting it back, and that can really jackpot an entire design that makes you look bad. When you're not focusing on that, it becomes The whole system needs to breathe, and if you can't breathe in, if you can't return the air to your so to speak, to your lungs, your air handling unit, you can't get it back out to the system. So you need to be able to go both ways as far as return and supply in the ductwork. So take some time and making sure that everywhere you're dumping air in, air can get out. And just go space by space, methodically. Make sure that it all works. If you don't, transfers and things like that. So a lot of times, what I see and the problem that comes into play is sometimes you're going to have transfer air ducts if you have like a non-ducted return system. So you use transfer air ducts, and that's, to your mechanical engineer, that's very, very, or your mechanical contractor, that's something that's very explicit to them. It's a piece of equipment, piece of ductwork. They know they're going to put it in, not a problem. If you just say, I need a 12 by 12 inch hole cut in the ductwork between, say, an office space and a corridor, and you need to get the air back out of the space, that might be missed, a high percentage of the time by the drywall contractor. And if it's not the drywall contractor, who's going to cut the hole? Nobody. I mean, it's not their job. Even though you have it, you can have it on the drawings. It'll be one of those things that you hope you actually catch before the ceiling goes in. Otherwise, it may never happen. And I've seen time and time again where there is a serious issue with, because there's going to tends to be a line and a segregation, a separation of spaces. So you'll end up having air trapped in certain spaces around a core group of offices, or just there's a large corridor that you have to cross that air is not getting across, and that's going to really starve the unit for what it really needs, and you're going to get these high duct static pressure differentials, and that can cause noise, that can cause discomfort. If you have a situation where I had a situation where there was two halves of the building separated by a lobby, and one part of the lobby had a opening, and the receptionist sat right in front of that opening, and the wind was just driving through that opening. The return air was just driving because there was nothing above the ceiling to account for all this return air for half the building on that floor, and that was a really poor design and something that's easily forgotten. So just take the time to document where you need the air to go and what kind of openings you need. And if something, like I said, if you can just specify a sleeve, if it's not necessarily a transfer air duct, anything that's a physical product that can get put up in there in the ceiling space, that's going to be less often forgotten than just cutting a hole in drywall. So, all right. That's it. Those are the 6 areas that I wanted to talk about for this part 2 of ductwork layout. I hope you got something out of it. At least one of those tidbits might have sparked something that you've forgotten in a previous project, or maybe it's something that you want to share with somebody else. So if you do that, share this episode. So other than that, that's a wrap for this week. I greatly appreciate each and every one of you listening. Again, I was hope that was helpful to you. If you haven't already, sign up for my list at HVAC360.com and get on that mailing list. And there's even additional tips and tricks for you on that. And that's something that I can get out on. I usually get it out on a pretty regular basis on Fridays. I've been very consistent about that, less consistent than I have on these podcast episodes because of the workload going up and down, in and out. And if you want to do a little bit more other than sign up or share this episode, go ahead on iTunes and share a rating and leave me a review. That gives an opportunity to get this podcast in front of more people and help them out. Maybe, save them, hundreds of dollars or hours in time. So other than that, if you do that, I'll give you a shout out. But that's it. All right. Signing off for this week. This episode of HVAC 360. Remember, I'm your host, Matt Nelson, helping you go further faster in the field of HVAC. And as always, know what you build, and share what you know.